Here we have the original motor out of the lathe. This is made by General Electric, 5 horsepower DC, compound wound. So we've got several sets of windings. There's the armature, the series field, and the shunt field. And the shunt field actually has 2 pairs that can be wired in series or parallel for 120 volt and 240 volt operation. Just going to run it with a 12 volt battery. This little guy, this is out of one of those booster packs. Here goes nothing. So it appears to be working fine. I'll get the megger and give it a good look-see, just to make sure there's not any sort of damage to the windings or, you know, insulation failure, that sort of thing. I didn't blindly go into this. I did a quick test just using a multimeter, which is not an accurate way to do it, but it'll tell you if you've got a dead short between any of the windings or a winding to motor case. And I had a feeling that the motor was fine anyway. I think it was replaced when it wasn't the root cause. So this is good. I may actually put this one back in. I have to get a gasket for the gearbox because this whole end plate was taken off, and the forks for the gear weren't engaged right. So I went in and put that back together just to see if it would shift, and it does fine. Down into back gear, and this, we'll see if it'll handle the motor's not spinning very fast because, I mean, it's just a little 12 volt battery, and we'll see if the extra drag can get overcome. Oh yeah. So now you can kind of see the gear reduction working. It's 5 to 1. Of course, with the camera shutter speed, it may all look like gibberish. That's good. A little bit of a clunking noise. Yeah, maybe nothing. I don't know. Might have a bad tooth. Wouldn't hurt to take it apart again. So at least there's hope. And the back gear on the other motor is fine, so I can, if I want to put this motor back in for posterity's sake, or maybe an original motor is actually better than a rewound motor, depending on who rewound it. But anyway, worst case scenario, I can stick with what's in there. I'd rather have this one back in, and it'd be nice to have the original gearbox, but if it turns out there's a damaged tooth on that, I'll use the gearbox that's already in the lathe. Here we are. We're going to see if we can get this motor yanked out real quick. See how much trouble it's going to give us. It's pretty heavy, but we'll see if I can manhandle it. It's got a creeper here with a board on it. We'll just try to slide it out. Anyway, let's get to it. Feels pretty good. Very good. You know, it's weird. I must have like 10 Phillips screwdrivers, and I've got 2 flat heads. I got this one that's too long and another one with a broken tip. Alright, these are hooked up with little ring terminals and screws and nuts. The tags are still on the wires, at least on this one, so that's good news. Here's a split loom that was put in here. We're going to get rid of that and get some more non-metallic drip proof. Aha! This one was loose, so that might be our clunking sound. And this other one is all the way out. No wrench needed. One motor out. Oh yeah. That fan's as loose as it can be. So, come in and take a little closer look at that. So here we are at the hind end of the motor, and then right in here is our fan impeller. You can see it's a little bit wiggly that way, axially. And it has a little bit of radial play also. Oh, actually, no, here a little bit. It's not even locked to the shaft. I'm spinning the motor right now, so you can see. Just put that guy in there. So this was probably under low RPMs, vibrating like hell. And then also both of these back mounts were loose. And then when we go through a high-speed maneuver, or a XL decel, a fast change in angular velocity, this thing would keep spinning one way or the other. So I guess I gotta take this plate off to get to it. So we'll do that and see what we see in there. Come on. So we've got a spring washer. Keep that in there. And so this bearing is most likely going to be a press fit. I see two set screws about 30 degrees apart. Alright, let's look in here. If I was a betting man, I would say there's a keyway in the shaft. There's probably a keyway in the impeller, but I don't think there's a key in there. And most likely it was just held in by those two set screws and they vibrated and backed out. So I'm going to have to pull the bearing off this shaft, pull this whole assembly out, check, see if there is a keyway slot in here, see if it's damaged, see what the motor looks like, the shaft, see if it's okay. And hopefully it'll be pretty straightforward. So here's my 3-jaw puller, and the jaws are too fat to get behind the pulley. So just bolt them all together and then go after it with a 4.5-inch angle grinder. Use the cutoff wheel and then finish it up with a flap disc. So just ganged them all up, made it easy. So they should be able to fit in there now. Give it a try. You rattly bastard. Alright, so we got a size for two different keyways, looks like. There's no key in there, no sign of any key. It's good to know. So you can see there's the machine keyway. I'm not sure what this giant guy is. There's absolutely no damage. No signs of having a keyway shear off or anything, just like it was never put in. And these set screws, it appears like they were never tightened. I'd find it hard to believe they backed all the way out flush with the casting. Alright, we'll probably put this guy to the side for a while. I'll have to order a new bearing and throw the GE in there, see what happens. Hey there. You gonna help me fix it? Do you know what's wrong? Is it broken? You have to pardon the dryer running in the background. But here we have the two motors I got. They're both 5 horsepower. The one on the left is an Imperial, and the one on the right is the General Electric. And the one on the right is the original one. I don't think I can remove the gearbox from this one without destroying the gaskets. So I'm just going to try to make a gasket for this one And I'm also going to check the brushes on this one right here just to make sure that they're okay. And the cool thing about the GE comes with a little plate right here. It tells you how to remove and install the brushes. So this is the brush holder right here, and essentially you just push in on this spring-loaded guy and pull up. That comes out, and then there is the brush. So I mean, there's a fair amount of material left on that, so I think we're good. And I pulled out the other one. It looks exactly the same. So I think we're going to be okay brush wise, and they're pretty easy to get to. And then you just push that in until it clicks into place. You kind of have to rock it forward to unlock it, and rock it forward to relock it. So looks all good. So we're going to pull this front cover off. See how hard it's going to be to make a gasket. I can order one from Monarch. It'd probably be pretty cheap. It's just a paper gasket. But I'd like to get this thing in and running today. It'd be really great if I had the right size Allen wrench. Just wasn't holding my tongue right. Let's not take that guy out. You ever get on autopilot and just do something completely asinine? That's like half my life. See, that goes all the way through, so if I try to take the one off the other one, it's going to break both gaskets. So I'll just leave it intact. This one had a little bit of a tick noise in it. I'll double check the gears while I'm in there. It could just be completely benign and may disappear, but it doesn't hurt to give it a double check. Alright, so this whole thing's going to come off, and the shift fork's probably going to fall out of place. It'll end up being a disaster. Don't want to pry too hard. I think it's just binding on these dowel pins. Just a real close tolerance. There we go. So actually, maybe I was wrong. Maybe this gasket wasn't that. It's definitely there. This was a few months ago, so my memory's probably just failing me. So here we have the inside of the gearbox. And this is a double shift fork. So this right here is your 1-to-1. So this is there's dogs here that engage the inside of this front ring gear. Provides direct drive to the output. So with the lever up, you're in 1-to-1. So when the lever goes into back gear, the teeth on the back side of this gear mesh with this gear back here, which turns this gear, which turns the outside of this gear for a gear reduction of approximately 5-to-1. So I'm just going to get in here and look at all these teeth. Just double check again, make sure I didn't miss anything on the first inspection. And looks like our gasket is actually in pretty good shape. It's still stuck on there, it didn't break. So I know it'd be better to put a new one on there, but I'd like to get this thing running tonight. Okay, now it's all coming back to me. It was the back side gasket that was messed up. The front one's fine. So this will be easy to make. Doesn't have to be anything special. I can just trace that out, cut it, make sure I got my hole here, and should be all good. So when you pull this part off, this drive gear right here comes off of its fork. So makes it easier to inspect. And anyway, I looked at all these. and just has normal run-in wear. Nothing major. Should be good. And so we just set this carefully back in place. So to reinstall it, you just slide that in. You got to hold that while it slides over that shaft. But I'm going to make a gasket for that real quick, and then we'll put it all back together. Oh, and I checked the sump down here. There's no shavings or anything, so it all looks pretty good. Got a nice brand new razor blade. Just going to clean the surface up. Some guys like to get crazy with roll-lock discs, Scotch-Brite pads. I prefer using a brand new sharp razor blade and preserve as much of the original machining as possible. Fingers are the best tools. Let's see if you missed something. Because this looks pretty gnarly, but it's actually nice and smooth. A lot of staining. Hit that little ring one more time. I'll do the same thing whether it's steel or aluminum. For aluminum, I'll take some high grit sandpaper, like maybe, I don't know, 2000 grit, and take the blade and rub it backwards just a little bit, and I'll also grind the corners off so it doesn't dig. Just some little tips. Alright. Yeah, that's good. So we're just about ready. One little spot there. Alright, time to lay a gasket on there. So here's something kind of funny. 1997 4Runner master cylinder to booster gasket. Apparently parts were hard to come by that day, and so I ended up making one just to save some time, get the car out the door. And I saved that pattern because apparently it was on eternal back order, intergalactic back order, that's what we called it. So anyway, I'm going to pull it out to a fresh section of this and get it on there, and we'll do a little trace or a transfer. And this here is the inside flange of the gearbox. I'm actually going to use this as my pattern. So I'm just going to clean this guy off like we did the other. Alright, that cleaned up nicely. Just give her a wipe down. Alright, so these dowels are in there. They're pressed in pretty tight and they're super hard. I can't really get a good grip, and I don't want to booger everything up. So I'm just going to lay this on there like so. And I've already done the first one. So just take this and lightly hammer around the edges. Pop through. So those are located. Now we need to find our bolt holes. There's one. And 4. So now, probably won't try to cut it all the way. I'll just make a rubbing. Another way to do this is you can just scan it, use AutoCAD, and then take it to a local laser cutter. You just import an image in AutoCAD and draw your lines on top of your casting, and then you know, most local sign shops have a laser cutter, so you can just take it in with a piece of whatever stock you want, and you know, it won't be too big of a charge, so you can get a custom one-off gasket. Alright, let's see what it looks like. If I got enough data imprinted on the other side. So, not too bad. I need a little more right in here. You can kind of faintly see it. Put it right back on there. Not sure if that bearing section came through. So now I've got something to work on. Just get a knife and cut all that out. And we'll see how it fits. So right now I'm just going back to these holes, just cleaning them up, because you're just rubbing through. You'll leave a little thick section right here. Probably by these big bolts it doesn't matter. By the dowel pins, you know, it may create a weak spot in the ceiling because it's keeping the castings apart. So I'm just taking these little hole punches, putting it right on top, and it kind of lines up with the burr on that, and so make a nice clean hole. I'm sure no one wants to see me spend 10 minutes cutting this out. If I'd have been smart, I'd have held it down this way and rod. It's a little easier to hold it down flat this way than to hold it down this way, because it's, you know, it's always fighting. You try to curl up. But anyway, I'll suffer through it. Here we are. We got our gasket made. It fits on there nicely. I know some of you be like, "Hey, that's way thicker than the original gasket," but it shouldn't really make a difference because the gearbox will just sit a little further out, you know, by a few thousandths. This will have a few thousandths less engagement, and it really shouldn't affect anything. I'd be surprised if it does. So, because this is self-contained, and I'm not changing the relation of this to the front plate, which has this gear on there. So the only thing it's changing is the engagement of this shaft on this right here, and so it'll be a little further out, but maybe like, you know, 10 thousandths or so, which isn't a big deal. Yeah, there's a couple ways. I could spray some high tack on here and stick it in place. But I'll probably just finagle it by hand. Make sure I line up my little bushings there. Yeah, come on. A little closer. These bolts will help line up the gasket. Here we go. All that's lined up. Lightly snug these up. So that is our direct drive. That is our back gear. Now with all that good, go ahead and give this a little snug up. Go around one more time. Make sure nothing's loose. Alright. So now, gotta trip over this. Gotta take this pulley off. Alright, now my question is, there's a shim right here. So you measure that depth to make sure this, when there's a shim there, it is the same. So I'll be right back. So here's our handy dandy measurer. This is just an old Etalon vernier, however you want to say it. So I'm just going to use it as a comparator. So yeah, that is right. So this guy should just slip on there. Make sure those threads are clean. Actually, I might just spray some WD on there. WD-40, the cleaner of champions. Alright. Oh, that's snug fit. There we go. Take a little cover here. Let's see which one's the best looking. Got one with crap all over it. Yeah. 6 in one hand. Not that this really matters, it just makes me feel better. Do one more round. Put some lube in it. Get it back in the lathe. So here's something pretty funny. The lathe came with a coffee can full of nuts and bolts, and so some of this stuff is just like old little projects. But I found something. What does that look like? A 1/4 inch keyway, maybe? Thought y'all might like to see that. These lathes are notorious for leaking. This is just going to get dirty again, greasy, and collect dust. But I will just give it a spritz down with WD and wipe it out. At the very least, it'll help keep dirt and crud out of my thread holes when I slide the motor in there. Now I'm going to check and make sure these are all tight and locked to the base. So maybe a 3/4 or 7/8. We're all good with that. Here's the fun part. Well, I suppose I should wipe the motor down too. I know this is not a cost-effective cleaner, but I don't really use it that much. Kerosene's a good bit cheaper. It's good enough. We'll just get all cruded up again. Yeah, the moment of truth. Here's where you get to watch me get a hernia. Heavy. Yeah. I think I'm gonna have to ramp it up there. Oh no. Don't want to fool with a jack. Alright, just gonna make that 1-inch jump. Tear up the motor before I get it in there. Work smarter, not harder. Don't want to have to do this. Well, we'll get the cherry picker over here. I'd scratch the cherry picker. It was just a little camera shy. And I think I understand why they left this bolt completely loose. Because I'll hold off on tightening. Put the belts back on. Make sure everything coplanar. I guess I don't have a whole lot of movement. It's pretty close. We got the motor in, got the belts back on, put some gear oil in there. It's DTE heavy medium. And I got the wiring temporarily connected, and I'll have to stop at the store and get some fittings for the non-metallic liquid tight conduit. It's the last thing to do. Got to hook up that shift linkage and get it adjusted. Let's pick a gear. I'm going to do back gear. Alright, so we're firmly in back gear. And I got the selector in back gear. So all I have to do is undo the lock nut right here. Then unscrew this until we can get our pin through the hole and all the holes lined up. So I'll give it a try right there, not quite. Okay. It's a pretty good fit. Let's see what one more feels like. That's perfect. So it's a little loose in the hole, but we're centered on that, and the detent's detented. And so we'll just pop our other cotter pin in. Right, here's the interlock. Alright, I think we're good. Do a few last minute checks and then we'll fire it up. Don't forget to relock your shaft. Don't have to kill it. Let's give back gear a try. Might have to recalibrate since there's a different motor in there now, but it seems to be working pretty well. We'll let that run in a little while. Uh-oh. Alright, what'd I do?